Great. Welcome everyone to our webinar for today. I am Sonia Aggarwal and I am the CEO of Energy Innovation, which is a climate and clean energy think tank that works a lot on policies to reduce greenhouse gas emissions while creating economic benefits and making people's lives better. I spent a couple of years as a special assistant to President Biden focused on climate policy as we worked to try and deliver on the promise of large step forward for the climate under the Biden administration. And I am back at Energy Innovation now and very happy to be here with you all for this webinar. So just to kick us off, a little bit of orientation on the moment we're in. It is just an incredible time in American history right now. The opportunity is right in front of us. It's ready for us to grab, to breathe life into our manufacturing communities right now. And I'm guessing that if you're joining this call, you have seen the incredible headlines that are coming out about first-of-a-kind projects to get us on the path to zero-emission factories. You probably know even more about what's behind the headlines than most people. And you probably are tracking that 600 factories have been announced since the passage of the Inflation Reduction Act in terms of clean energy manufacturing and clean manufacturing here in the United States. I think the headlines of the last month or so have focused on the $6 billion demonstration program from the Inflation Reduction Act that's being administered by the Department of Energy. But I just want to remind everyone that that's just one of a very large suite of new efforts that are being taken right now at the federal level here in the U.S. to kickstart our modern, clean industry here in this country. So there's programs like 48C, which is a tax credit for factories that reduce greenhouse gases, grants for industrial research and assessment centers that I think Kelly will discuss with us today, all the way to smaller programs that enable all of this work to actually get to scale, programs like funds for environmental product declarations, integrity coming out of the Environmental Protection Agency. And just as you can tell, I think this is really just the hottest new area for work right now, and I can't wait to dig into a little bit more of this with Jeff and Kelly. So on that, Kelly Visconti is Deputy Director for Manufacturing and Workforce Development at the Department of Energy's Manufacturing and Energy Supply Chains Office. And I thought the world of Kelly's work when I had the opportunity to work more closely with you when I was at the White House. Jeff Rissman is Energy Innovation's own Senior Director for Industry and one of my favorite people I've ever worked with. And he is the author of a recently released book that gives us really the first ever blueprint roadmap for how we hit zero emissions in the industrial sector. So with that, perhaps I will turn it over to you, Jeff, if you want to provide a little bit more of your own intro, and then over to Kelly, and then we'll move into presentations. Thanks.
Sounds good. Thank you so much, Sonia, and welcome everyone. So yeah, as Sonia mentioned, I'm the Senior Director of the Industry Program here at Energy Innovation. So we do research and writing and data analysis on essentially how to accelerate a transition to clean industry and clean manufacturing in a way that promotes jobs and strengthens communities. My presentation, which you'll see in a few minutes, is just a few little tastes of what you might see in my new book, Zero Carbon Industry. So I can't wait to share that with you. And prior to this, I was the creator of the Energy Policy Simulator, a multi-sector open source energy analysis computer model. So why don't I turn it over to Kelly if you want to say a few words about your background?
Great. Thanks, Jeff, and thanks, Sonia. Really glad to be with everyone to talk about one of my personal favorite topics, industrial decarbonization. And it's nice to have people joining in the conversation. So I've been at the Department of Energy for about a decade and spent the first 10 years of my career in the private sector. I'm a chemical engineer by training, worked in the chemical industry, and then came to DOE. And sustainable manufacturing has been kind of the core of that work for me. And now I have the opportunity to serve in our Office of Manufacturing Energy Supply Chains, one of the new offices stood up in the last 2 years. We are executing and managing about $20 billion worth of Infrastructure Law, Inflation Reduction Act, as well as a little Defense Production Act funding to help transition everything we need for clean energy supply chains, from cleaner, low carbon materials through components and subcomponents and systems levels for clean power, transportation, industry, buildings, kind of the whole economy wide, and really that core around the manufacturing part. So excited to tell you more in my presentation, but I will kick it back to Jeff to get us going.
Sounds great. Thank you, Kelly. And I'm going to share my screen and share some slides with a little bit about my book. So here we go. Wait for it to come up. All right. I think that's up. So these are some highlights from my new book, which is titled Zero Carbon Industry: Transformative Technologies and Policies to Achieve Sustainable Prosperity. So why write this book in the first place? So the industrial sector globally is responsible for about a third of human-caused greenhouse gas emissions, including those from purchased electricity purchased by industry. If you disregard the purchased electricity emissions, it's about a quarter of global human-caused emissions. Either way, it's a huge piece, and we can't stabilize Earth's climate at any temperature unless we shift to clean industry and get these emissions down. So that's the importance, but also there's the need for this book as a tool. Industry has been seen as a hard to abate sector, whether due to complexity, the profusion of manufacturing processes and products that they make, that industrial firms make, or economic concerns, whether or not policies can promote jobs and competitiveness and what to do about trade exposed industries. So there are so many exciting technologies now to decarbonize industry, but the information about them has been scattered across many different publications, technical research reports, academic studies, and often the technology information is divorced from the policy information. So there was really a need to bring it all together into a comprehensive blueprint or roadmap for how we get from where we are to how things will be made in the future in a clean, sustainable way. This is just the table of contents, which is actually a good way to take an overview of like what is the snapshot. I, of course, won't be able to touch on all of these topics because we only have less than 10 minutes here. So I'll say a little bit about high-level things, a tiny bit about electrification, a bit about steel. So quickly, for an overview, when we're talking about industry, what we're talking about are the firms that make the materials and products we rely on every day, like steel and chemicals, which includes plastics and fertilizers, cement, other metals, refining, and so on. And you'll notice that globally, about 60% of the world's industrial emissions are from these top three industries: iron and steel, chemicals, and non-metallic minerals. As far as distribution goes, China stands out as being responsible for about 45% of global industrial emissions, partly because of their large scale of manufacturing and partly because they use a lot of coal, which is a particularly emissions-intense fuel. India and the United States, and then the European Union, if you were to group together those countries, would round out the top four. So let me touch briefly on some of the exciting new technologies for primary steel production without greenhouse gas emissions or other pollutants. So today, steel making is a multi-step process. You prepare the raw materials, you make iron, and then you turn the iron into steel. It's dominated by primary. So primary steel is the majority of all steel making, And most of that, 93% of primary iron is made in a blast furnace, which is fueled by coal and a carbon-based fuel called coke. There is some steel recycling, responsible for about 22% of demand, but it can't scale up very much because we don't have enough scrap to recycle to meet today's steel demand. So it's important to develop technologies that can decarbonize primary or non-recycled steel making. One such technology approach is hydrogen direct reduced iron. So instead of using that coal and coke I mentioned in the blast furnace, you can use hydrogen as a chemical reducing agent in a DRI, or direct reduced iron furnace. And this about 2/3 of the energy that this requires is making clean hydrogen in an electrolyzer, which splits water into hydrogen and oxygen. And the remaining 1/3 is used mostly in an electric arc furnace that converts that direct reduced iron into steel. It does require high quality ore, but it's possible to upgrade lower quality ore through magnetic or gravitational separation. So that isn't a hard and fast limit on the direct reduced iron process. And there are some exciting example projects now. In fact, 2 that were part of the recently announced projects with the Office of Clean Energy Demonstrations in the United States, one with SSAB and one with Cleveland Cliffs, as well as a variety of projects elsewhere, like Hybrid and H2 Green Steel in Sweden, ArcelorMittal in Germany and France, and so on. The other technology I'll touch on here is electrolysis. So the idea is, instead of using a chemical reducing agent like hydrogen or coal and coke to separate iron from iron ore, you instead use electricity to do that. You can either do this in an aqueous or a solution where you insert electrodes, run a current between them, and metallic iron particles deposit on the cathode, and you can then collect them and melt them in an electric arc furnace. Or you can do this at high temperature in an electrochemical cell, where you still run a current through it, but it's at high temperatures. And then the impurities form a layer of what's called slag on the top, and molten iron forms on the bottom of the chamber where it can be tapped. Both of these approaches have some startups, Electra for aqueous electrolysis and Boston Metal for molten oxide, as well as research projects primarily in Europe with Ciderwin and Europe Ulcos, ultra-low CO2 steel making. Have to keep moving along because we only have a few minutes left, and I will touch on some of the electrification of industrial processes. So this is a graph of the United States fuel and electricity use by the industrial sector. You'll notice a lot of the fuels are feedstocks. Those are fuels that go into chemically making up the output products like plastics and fertilizer. They can't be directly electrified because they contribute mass to the output products. The largest piece of fossil fuel use, though, is the center row, where fossil fuels are being combusted for energy. And the vast majority of that energy is to provide heat. Heat for things like melting metals or driving chemical reactions or boiling water to make hot steam, which is used in a lot of different industries. The small bit on the right are other things like machine drive, which is moving things, let's say with a diesel engine here, and is usually easy to electrify with an electric motor, for example, for machine drive. So when we're talking about decarbonizing industrial fossil fuel use, combustion, we're mostly talking about decarbonizing industrial heating. And there are a variety of technologies that can provide heat for industry directly from electricity. I won't read them all off, but I've listed them here. And I'm going to touch on a couple exciting ones, just to do a little bit of in-depth on heat pumps and thermal batteries. So what are heat pumps? They're a way of moving heat from one place to another. They use a refrigerant fluid in a closed cycle, similar to your refrigerator or air conditioner at home, to move heat from a heat source area to a heat sink area. And they can be very efficient, up to 200 to 500%, meaning the amount of useful heat they deliver to the heat sink, heat output area, is that many times the amount of electricity they consume. And they can do that because they're not converting the electricity to heat. They're just moving heat from one place to another. And this allows them to to be very financially competitive because they reduce the amount of electricity you have to purchase. Just briefly, here's a graph showing the efficiency of heat pumps with relative to the temperature increase they deliver on the x-axis. So one common application would be to boil water, say, which is enough for a lot of industrial processes like cooking foods and so on. If your heat source is 30 or so Celsius, then your temperature increase would be 70. And that's more than 2.5 coefficient of performance, more than 250% efficient compared to a perfectly efficient electric resistance heater. So you can see that heat pumps are the best, most efficient at relatively smaller temperature increases, but they're still quite efficient up to higher levels shown here. The other technology I want to highlight in my limited time is the thermal battery technology. This is a way of storing heat to use later. Essentially, it's a thermal storage medium like graphite blocks or silicon dioxide sand that gets heated by an electrical resistance heater, coils of wire essentially, which take in electricity from the grid or from off-grid projects. And then when the industrial firm needs the heat, they can either circulate a gas like air through the battery, and it takes the heat out and is used in the facility, or they could open a hole in the case to let out visible and infrared light. And the interesting thing about this is that it lowers the cost of industrial heating. So this is a price comparison. This this shows what, in green squares, what the cost would be if you just bought electricity evenly in every hour of the day. The red diamonds are thermal batteries, where in this case it's with off-grid renewables, but the results are quite similar for on-grid because they can purchase electricity in the cheapest hours. And it cuts down the price down to a half to a third of what it would be if you just bought it straight from the grid evenly in every hour. And it's enough to make it competitive within the range of natural gas, keeping in mind that natural gas prices are volatile and they move around year to year and place to place. So it's good to think about rough ranges rather than exact numbers. I will not really spend much time on policy since I'm pretty much out of time, and I think Kelly will touch on some of the exciting things DOE is doing. I'll just show this one slide with some high-level overview of some of the things that policymakers can do, whether that's emissions and energy efficiency standards, green public procurement, financing policies such as financial incentives, cost sharing, loan loss reserves, green banks, equipment rebates, as well as R&D and technical support through things like national lab partnerships, the Better Plants program, and so on, as well as carbon pricing, which is used in a variety of U.S. states and countries internationally. So thank you so much, and there'll be time for questions later, but for now I'm going to turn it over to Kelly.
Great, Jeff. Thank you so much. And thanks, Silvio, for pulling up the slides. I think Jeff just set the stage really well for the challenge, why this is such a critical area, and some of the key sub-industries we need to focus on given the size and the overall impact, as well as some solutions from a technical perspective, and very much see similar view of the world from Jeff's perspective there. I'm just going to share a little bit more about what we're doing at the Department of Energy to try and solve some of these challenges and address the technology gaps and move some of these technologies further into the realm of commercialization and address some of the barriers along the way. So if you go to the next slide, please. So I have the privilege of serving as one of 3 co-chairs for what we call our Industrial Technologies Joint Strategy Team. The Department of Energy has a range of tools in the tool belt, and the passing of the Infrastructure Law and Inflation Reduction Act gave us many more, not just in terms of the amount of funding we have to try to tackle this problem, but the kinds of programs and resources we have that we've really, frankly, never had at this level in the past. So historically, the department is focused around research and development type activities, really taking and innovating technologies, everything from the basic sciences and what our national laboratories do, really taking that to beyond laboratory scale into pilot scale testing. And then we've had work in partnership with industry to really help understand and get companies to adopt these technologies. But with Bill and Ira, really it was this big tranche of activity and funding to really help move the needle in large scale, commercial scale demonstrations that we've not been able to really fund before, as well as addressing some of the deployment challenges. So the 48C tax credit is a great example of how to help drive the economic case for using some of these technologies that Jeff pointed to. So this whole of Department of Energy approach, we have aligned 10 different offices that have a different piece of that puzzle into one working group, our joint strategy team, chartered by the Secretary and Deputy Secretary to develop an integrated strategy to make sure we are coordinating internally and actively engaging all of those pieces of the puzzle, and that we're engaging externally. So my role in serving as one of the chairs of the joint strategy team is engaging with folks like Jeff and Sonia and being here with all of you today to talk about the work in an integrated way. So really our mission is to try and drive energy efficiency and decarbonization technologies that help reduce emissions and are going to help increase competitiveness as we move forward in a net zero economy for the future. And we've also identified metals, chemicals, and cement as really key end use sectors that we need to focus on, given the size, not just in the United States, but globally, and really looking at these cross-cutting approaches around electrification and efficiency as some of the key near-term levers while we're developing the economic case for some of the others. So just to kind of give you a snapshot of one of the roles that I play within the department, and I'm happy to serve as a integrator and help you find if you're looking for resources or expertise, or do we have certain kinds of programs. I'm happy to serve that role to help orient folks as they're trying to land. And at the bottom of the page, one of the things we created was a one-stop shop website that has all of the industrial related work within the department. So you can find analysis, you can find roadmaps, you can find funding opportunities, you can find recent announcements, all in one place at that industrial technologies link down below. So just kind of to give you an overview. If you go to the next slide, please. So again, this picture is just showing a little bit more of that commercialization timeline pathway from really something from an idea in that bottom left corner all the way through something that is a commercially available and adopted technology, and the different offices within the Department of Energy that are really helping drive down different kinds of risks, reducing technical risks, reducing project level risk, and really understanding and helping drive down market risk. And you can see the office that I sit in the blue, dark blue on the bottom right, manufacturing energy supply chains. We are really looking at how do we have and help companies overcome market barriers, the cost, the economics, making sure that there's demand for these products to help move the needle and really get these solutions into the factories and into the plants. If you go to the next slide, please. And this is just a little bit more of that mapping and landscape. And this speaks a little bit to what Jeff was talking about around the different types of solutions in how you can decarbonize these industrial processes and manufacturing overall. So if you look, there's 5 columns, but if you look at the 4 columns on the right, this is about switching your source of fuel, your source of feedstock, and energy. So this is that electrification transition that Jeff was talking about, as well as using alternative fuels and alternative feedstocks as one solution set. Energy efficiency, basically doing as much as we can with the electrons and the heat that we're putting into the system, absolutely essential and something we need to continue to drive. There are many opportunities still on the table for energy efficiency today. The third bucket is more specifically around electrification, not just for providing heat, but there are electrochemical based processes that we can explore and utilize versus traditional thermal processes. So rather than using heat to make a reaction happen, there's different types of electrically based processes like microwave technologies or radio frequency that can make the chemicals react and do different things. And then the last solution we talk about as a category is around carbon capture. So in those situations where the technology isn't mature enough, or we just still fundamentally, because of the process chemistry, have carbon dioxide coming out, how do we capture it and then either utilize it in some long-term material, say cement and concrete, and be able to take advantage of that and make a valuable product out of it, or to store it safely and securely underground. So if we look at those sort of 4 pillars, the 5th one is around making sure we actually have the equipment to do all of these things. So for example, there are certain specialty materials that are used in carbon capture systems. And so we need to have enough of those kinds of chemicals and systems and equipment available. So our Advanced Materials Manufacturing Technology Office within EERE really helps make sure we have those solutions. So you can kind of just see the mapping of all the different pieces within the Department of Energy, and our joint strategy team basically encompasses everything you see on this slide. Next slide, please. Yep, that's great. And just sort of, we've got a lot of different documents and information out there. Just 2 things I want to highlight. So 2 years ago, the Industrial Decarbonization First Roadmap was published in concert with a lot of engagement with industry. And that really helps set the stage of everything that could possibly happen and set that framework of those 4 big pillars that we talked about in the last slide. On the right-hand side, and that puzzle piece there, the pathways to commercial liftoff. These were published last September. There are 3 reports that are really helping show what are those technologies and solutions that are near cost competitive or cost competitive today that can be used by industry in the next 5 to 10 years. And we're working on a joint strategy that's really integrating all of these pieces together. So I look forward to reading Jeff's book, and I'm sure there'll be some great pointers and tips in there for us as we are taking a peek at how we do this together. And then these feed into things like our multi-year program plans and how we establish the objectives and goals and funding opportunities, make project selections, and then ultimately the funding that we go out, make sure it's doing what it's supposed to be. So if we go to the next slide, and then I think I'll wrap up just with a short overview of some of the programs that we have. To Sonia's point around, yes, a lot of attention around the industrial demonstrations program and the over $20 billion that's unlocked across 33 different projects across multiple industries and process types. Super exciting program. There are a few other opportunities still out there that we want to make sure folks are aware of. So again, work in the Manufacturing Energy Supply Chain Office, and we're really focused on that how of the energy transition, making sure that companies are actually using the technologies and solutions that are available. Next slide, please. So here is a summary of 3 active programs that have funding still available. The first is focused around the industrial assessments and implementation grants. These are focused on small and medium-sized manufacturers. You can get a free assessment to help understand your energy and emissions reduction opportunities. Once you've had one of these free assessments, you are then eligible to compete for $400 million worth of funding to implement those in grants. Each of those grants is up to $300,000 per project, per company, per quarter, and that has to be 50% cost share. The program's been expanded in multiple ways, and there's a big workforce development component around that too. The second program, our Advanced Energy Manufacturing and Recycling grants, our second round, our concept papers are actually due today. So if you haven't heard about it, I apologize. There may be a third, but we're hoping to expend the $425 million we've got left. This does include industrial decarbonization. So all of the things that we've talked about so far in this presentation would be potentially eligible for small, medium-sized manufacturers that are located in coal transition communities. And then the 48C investment tax credit is open to any size company, and industrial greenhouse gas emissions reduction projects are one of the 3 eligible types of work that you can do under this program. The first round closed of $4 billion, and I think about 30 companies self-reported that they were selected for this tax credit, and you can find more information about who they are and what those projects are on our website. And then a second round, this is important, is coming soon. in 2024, and there'll be $6 billion, the remaining of the $10 billion for this investment tax credit. And it works a little bit different than a grant, but fundamentally it helps with the overall economics of industrial greenhouse gas emission reduction projects. So that's a really super short overview of these 3 programs. And if you just click to my next slide, just so I make sure I didn't miss anything. Again, this is a snapshot of the IDP program. It's $6 billion in federal funding, leveraging private cost share, getting to about $20 billion. Estimated 14 million metric tons of CO2 that'll be avoided. There's a lot of co-benefits in reducing other criteria air pollutants, creating tens of thousands of jobs, and many are committed to union labor and good quality jobs. So really exciting program from the Department of Energy for sure. And one more, please. Great, and that is the wrap up. So you have a link and you can reach out through the MESC website and email there. Happy to answer any more questions and look forward to the dialogue and discussion. So thank you very much.
Thank you so much, Kelly, and thank you, Jeff. Really relevant and interesting presentations. Thanks so much again for those. Maybe I'll just kick off the discussion with a question of my own that's on my mind these days, and then we can open it up more to, I see a few questions have come in, but don't forget to type your question into the question box so that we can hear from these experts on what is most relevant to you. So just to start us off, it really sounds like there's a lot of opportunities. Kelly, what you went through was quite a list, really, of things that people can do to get involved and to get new projects off the ground. So I just wondered if you were to each both kind of step back and think about the most important things that people can be doing right now to make all of this become a reality, to actually get those factories not just announced, but built and operating here in the U.S., whether, you know, those people are the companies themselves, are finance providers, are state economic development offices, state policymakers, or others, whoever you want to speak to. What should people be doing right now to make this all happen?
I'm happy to kick it off with a couple thoughts, and then Jeff would love your add-on for sure. So I'd say first is just if you aren't familiar with any of the programs that I named, and there are others. So for example, the EPA has the Climate Pollution Reduction Fund that is for states to develop programs to help with climate pollution reduction. And if you're a company and you haven't been involved with your state offices that have expressed interest in this program, there's a published list. I highly encourage you to do so, because if you are an industrial company, you are probably potentially a large source of emissions within that state. And if they're not talking to you already about how you're included in their plan, that seems like a great opportunity. So first is just to be aware of the remaining opportunities. The second I'd say is no matter what the opportunity, in nearly every case, some kind of cost match is required. So engaging with private sector state level entities. If you're a company thinking about DOE grants, it's about 50%. If you're looking at the tax credit, you have to cover the whole cost of the project up front, and then you get the 30% tax credit after you've met certain requirements and the project is actually operating and been put in service. So I think the financing part, it cannot be underestimated in how important that is. And then the third piece I would say is that anywhere in the Department of Energy, any kind of funding that you are looking at receiving, whether it's a tax credit, a loan through our loan programs office, or a grant through any of the multiple offices that are still offering grants, our community benefits plan is a key piece of our selection and evaluation criteria, and engaging with local communities to understand the real impacts that your facility is having, and how your project could benefit and improve. And so for example, in the IDP, all the co-benefits of reducing criteria air pollutants, water pollutants, anything that's going to help the local community, jobs, workforce development, all of these components are really essential. and we're really paying attention. Just copying and pasting something you found on a website, we can tell. So we really want folks to be doing that outreach engagement, and there are a lot of organizations out there who are helping build this muscle, something that folks maybe just haven't been familiar with in the past. And so we're really asking folks to exercise new muscles. And there's a lot of great non-governmental organizations, local community organizations that are really helping build that. So I'd say one is just make sure you're aware and plugged in. And if you have any questions, I'm certainly happy to try and help. The second is the private sector financing is really critical. And that could be state matching, it could be banks, it could be internal capital, but what's your plan? And having that really solid is super important. And then third is making sure you're engaging early before you are even thinking about applying with your local communities to make sure your community benefits plans are strong. So those are the three general aspects for companies. And I'd say if you're a part of any of those ancillary groups, you have an opportunity to kind of support each of those elements. So those are my opening remarks, and Jeff would love for any other thoughts you have.
Sure. So that's a great overview of how to access a lot of the new funding and opportunities that are available, which is one of the biggest things one can do right now, because this is a special time with all of these programs happening, funded by the IRA and other laws. So you know, if you're a company, do recognize that now is the time to begin making these investments in moving to clean processes. There's also roles for others to play. For instance, state or local policymakers can and should encourage their local businesses to switch over to cleaner processes. The states that move on this may be able to secure these larger facilities, get the jobs associated with them, the technological leadership, and also future-proof a lot of their industrial base as time goes on and there's increasing demand for clean products, both within the country and exports to elsewhere. So I think if you're within an office of a policymaker or want to speak to a policymaker about it, you can point out that this is something that hasn't been on the radar enough, but now is the key time to really move ahead with this. And then I suppose if you're still earlier in your career and you're looking at what to do, there are lots of opportunities. You could become a scientist or engineer and work on these technologies. You could become a policymaker and help on the policy level. You could become a journalist or an author and help spread the word. It's really a team effort because this is such a big challenge to decarbonize industry, and it needs people coming at it from all angles.
Thanks to both of you. So we have one question from folks on the line about thermal batteries and how exciting they are in theory, and yet we have not seen very much deployment yet of this technology out in the field. So wondering if you all can talk about some of the barriers to deploying thermal batteries at scale and why you think maybe we haven't seen them deployed as much as their economic and technical potential might suggest we should.
I could take this one to start. So there have been thermal energy storage solutions in the past, often with molten salt associated with concentrating solar thermal plants. But the type of thermal batteries that I mentioned in my presentation with these chemically inert storage materials like graphite blocks and that are small scale, fit in an industrial facility inside, you know, a warehouse, they're fairly new technologically speaking. A recent survey globally that I saw identified about 32 manufacturers of the thermal energy storage solutions at a range of output temperatures, but some of these can reach 15 or 1700 Celsius, which is also new and is much higher than those molten salt systems of the past would be able to deliver. So part of the answer is the technological newness and that they're different from the thermal energy storage that came before. The other answer, I think, is that there are certain conditions that have to be true for them to achieve their big savings. Either they need an off-grid wind and solar project where you can buy electricity at very, very cheap prices because you don't have to pay any of the ancillary charges to maintain the grid, or you have to be in a place where the utility will transparently pass through its true cost to generate and deliver power in each hour of the day, which does vary with wind and sun and congestion and transmission lines, but some utilities will levelize that to greater or lesser degrees. And but thermal batteries thrive on being able to purchase electricity when it's cheap and not purchase it when it's expensive. So utilities may, in some regions, need to create rate plans for highly flexible loads that pass these costs through more transparently and let the thermal batteries realize their financial potential.
I think Jeff just said probably one of the biggest barriers for sure. I think the other is there have been some more demonstrations, and I actually think in the IDP program there are a handful of projects that are looking at thermal batteries, if I remember correctly. I don't have them all memorized off the top of my head. So I think it's also just large scale demonstration proof of concept that people feel comfortable with the technology and the whole operating model. And I don't think it's just the actual battery, but to Jeff's point, the electricity and the entire system and how it will function and operate, I think is really critical to prove out. So excited that we'll have the chance to do that and gain some more confidence.
Great. So we just have one more technology specific question come in, and then I think we have a couple of others as well. So maybe just I'll turn to that one since we're already on a technology specific conversation. Combined heat and power. Now that's a topic that for folks who've been working in this space for a very long time, it used to be the main topic, right, on a lot of industrial sector emission reduction opportunities. But in recent times, there's been some questions around, are we still moving in the direction of wanting to encourage combined heat and power, given its dependence on fossil fuel heating in most cases, at least. So just curious if you all can comment, perhaps Jeff, on kind of where you see the biggest emission reduction opportunities and where we should thus be focusing our efforts. And Kelly, if you can help us to understand the department's position on this technology as we move forward, that would be really helpful.
Sure. So combined heat and power, as the question notes, has been traditionally with fossil fuels. You could use it with sustainably grown bioenergy or the like, which could, if the bioenergy, as I said, is sustainable, could be carbon neutral. There's also, I think of it, it is a broader category might be waste heat recovery. So if you're burning fossil fuels, it's not going to be climate neutral, at least not without carbon capture additionally, and co-producing electricity doesn't make it carbon neutral. So CHP on its own isn't what I see as a solution for achieving zero carbon industry. But the idea of waste heat recovery is important and can work no matter the heat source, even electrical. So for example, I know modern cement plants can recover heat from their clinker, the product they produce, and use it to preheat materials earlier in the process that go into the kiln. So some of the things we may have learned from CHP about waste heat recovery and using it for electricity or for other purposes may still be valuable and important in an energy efficiency sense.
Yeah, and I can just sort of add on to that. I think in the long run, we're looking for net zero solutions, and there's also a practical transition of how we get there, right? And doing the most we can with the systems and the materials and the fuels we have today is better than not taking advantage of what we can. So if combined heat and power is going to help with the overall efficiency of an operation, that's better than doing nothing and continuing to burn, let's just say, coal as an example, right? So there's a transition pathway that we want to see. And the way we've been thinking about it is future proofing, right? I think is a word Jeff maybe used, or Sonia, in designing the equipment or enabling the equipment to be flexible fuel. That, you know, we are investing a lot of money in hydrogen hubs, and if hydrogen became available, you know, blended hydrogen or hydrogen as a fuel by itself would be a, you know, zero emissions, potentially, depending on the source of hydrogen, option. So, and again, I think we need to, in the long run, to Jeff's point, like, you're still burning fuels, so without carbon capture, it is not net zero. But we do recognize this is a transition and something that we need to be thinking about. So doing something certainly better than doing nothing, but we are also aware of wanting to avoid technology lock-in, where companies are investing in, you know, a system today that isn't flexible or can't be retrofitted easily. So I think it's thinking through the design of a system you might be thinking about today, so that if hydrogen became more available, or biomass, or some other fuel source that could be, you know, we want to be thoughtful about that, and not end up with another 20, 30 years of fossil fuel burning, where we have an option that just wasn't included in the original design of the system. So, you know, it's we have a lot of range of tools in the toolbox, and, you know, there's no single answer in any situation that's going to work. It's got to be based on what's the best available at the time, and being able to think through what you could do in the future as much as possible. So
Thank you both for that. So moving on from just the technology specific questions, there's one clarifying question for you, I think, Kelly, on
sure.
48C, just and what the timing may be for the next round of selections under 48C, if you have that information.
So the first round, the IRS notified individual applicants at the end of March. It is tax information, so we are not allowed to say who got what because it's tax information, but entities that applied and received the tax credit that wanted to self-announce and proclaim, hey, we got the tax credit, are able to do that. And I think we had about 30 companies that were a part of an announcement that went out. You can definitely find it on our MESC website or LinkedIn. There's probably some posts. Other companies that have not made that announcement, we can't share that information because, again, it's tax information. That's the first round of 4 billion. The second round, there's no selections to announce because the process hasn't even started. So I don't have a date. It is coming soon. The intention is to launch it in the coming months. And once that is open, then it will, I think it launched it took about a year, if I remember correctly, from the time the initial round opened till they made selections and in determinations to the companies. So again, it's a little bit of an unusual circumstance where normally when the DOE is working with a company, we're able to say, here's the selections. But in this case, again, because it's tax sensitive information, we are not allowed to share that directly. So encourage companies that are able to and want to. Certainly we would, you know, love for them to be able to share that, but that's voluntary. So hopefully that clears that up.
Great, thank you. So the next question is around our workforce that we have here in the United States and how we think about the transition from the existing way of making a lot of industrial materials to the new way that we must begin to make the same industrial materials, and how much of the skills transfer from the prior way of making these things to the new way. So the example in the question was around steel making, but I think there's probably a broader question as well, just around how much of the skills from the way that we used to do things are going to transfer to our new ways of doing things.
Sure. Happy to speak to that, because I think of this transition to clean industry as being a big opportunity for these industrial communities to grow or retain jobs. The type of work that's being done is very similar. It's largely the same. It's still steel making. It's still from iron ore, or in other industries, it would still be similar if it's making fertilizer or plastics. So while the changes in machinery may require some retraining in terms of which machines to use and how to use them, it's not like getting a totally new career, like becoming a computer programmer or something. Workers will still be able to use the same skill sets and abilities that they are familiar with, to produce these materials and products in a cleaner way. And then, just taking a step back to be a little broader, many of these companies are important employers in their communities. And so this transition is an opportunity to invest in those communities and the workers there, and make sure that these opportunities exist for them, while achieving co-benefits like reduced local air pollutants, like particulates that affect human health near the communities. So this is something that I think communities and workers in particular should be very excited about being a part of.
Yeah, I think I'll ditto everything that Jeff just said, and perhaps add on. I think the other really great opportunity is to be thoughtful about this transition. So if we look at some of the programs that I manage, they are targeting coal transition communities where coal-fired power plant or coal mine shut down 10 to 20 years ago, and the economic loss that created, we're trying to basically make up for it, right? And make sure these communities are not left behind by trying to attract new manufacturing, revitalized manufacturing in those communities. I think with the transition from steel to clean steel, and in the United States, we already have made a large transition to electric arc furnaces in a lot of the manufacturing, which is cleaner than the traditional operations. We can be intentional and thoughtful about it as a collective, and our programs around the industrial assessment centers and the workforce development components of the programs are really targeting that, trying to make sure that we are, where necessary, reskilling folks as appropriate. But I think to Jeff's main point, it's still cement, it's still steel, it's still the chemicals that we're talking about. Just the equipment and the actual process itself might change and need reskilling or retraining on exactly how you do it. But the overall product and working in an industrial environment, I think there's a lot of similarities that I think will translate pretty well. It's not a one for one, but I think it's a pretty strong overlap and match.
Thank you. And I think in some ways, the next question dovetails very much with this, centering on workers and thinking about communities in the way that you were also discussing earlier, Kelly, with the community benefit agreements. But it's a question about scenario planning for different political leadership that may come, whether that is in the near term or even in the next several years, and how we think about the durability of this transformation under those various scenarios.
I think what we're talking about is building more sustainable, reliable operations in a globally competitive marketplace for the most part. Most of the things we're talking about in this industrial landscape are globally traded commodity materials, and the world is shifting in a lot of different places. And so for the US to remain competitive, some of these things are going to need to change. And we also want to be thinking about the holistic picture. I think certainly we look at it from a carbon emissions reduction perspective, but some of the processes that Jeff laid out have a lot of other reductions as well, reductions in air pollutants, period, reduction in you know, environmental waste, reductions in water usage, in some cases more water usage. So there are trade-offs, right? There's fundamentally no perfect solution. And so I think for the way to think about this is really about that sustainability and thinking about this in a competitive landscape, to make sure that the United States, the lens that I, primarily look at working at the Department of Energy, is essential. So making sure that these solutions are economic, that we're driving out the cost wherever we can, and that we're taking advantage of the incentives that are on the table with the tax credits that are in place and will be in place for a very a longer time to come beyond really any political administration at this point in time, I think is important. So I think it's really incumbent on companies and others to be thinking about this from a strategic long-term investment. Yeah. So just some thoughts from me. Jeff would love any color commentary from the outside in.
No, that's great. I think that's absolutely right. These technologies are beneficial. They are beneficial to the economy and workers. They cut conventional air pollution, which causes heart attacks and lung disease. And no one on either side of the aisle wants heart attacks and lung disease, and everyone wants high quality jobs in the United States. And these jobs are spread across communities, across states all around the country. There's no reason that any of these programs should not endure and flourish, irrespective of administration, because they are beneficial for the country and workers and public health. So I think it's just important to keep that in mind. It's not a partisan issue. This is something that will help make the country stronger and healthier, and also help ensure our country's technological leadership on an international stage as more and more countries shift toward cleaner production.
Well, I think that is a fantastic note to end on. So thank you both very much for all the work that you are doing to ensure that we, have healthier communities, that we are making the things that are going to be in greater and greater demand around the world as we move into the rest of this century. It's really exciting work, and there's lots more that we could have discussed. And I know we didn't get to some of the questions. I'll let everyone on the line know that you'll receive an email from Silvio Marcacci within the next day. And if there are additional questions that you want to send our way, we would be happy to take those as well as a follow-up to Silvio's email. And thank you very much for your time tuning in today. And thank you to Jeff and to Kelly for all of the great knowledge and expertise that you are bringing to this very important topic. Hope to see you all soon.
Great. Thank you, Sonia.
Thank you,
Jeff.
and thank you all for attending.